So first of all, what is additive manufacturing? Additive manufacturing, for this explanation, is a manufacturing process, and you use it to manufacture parts, particularly mechanical components. So no electronic components and no liquids or anything else. But that's on the highest level. That's additive manufacturing. That's not FDM specific. That's not particle bed fusion or anything like that. Additive manufacturing actually encompasses a group of process types that can vary widely, from feedstock type to formation method and many other properties. So on the highest level, additive manufacturing. And you should not restrict yourself in terms of material or size, whether it's very small or very large. There's entire boats being 3D printed. There's something called micro SLS, where you can make parts on the micrometer level. That's 2 photon stereotography. So a very large range. And also materials, it ranges from ceramics to metals to polymers, flexible polymers, many different things. So if you think on that level, I would not I think we should not restrict size or material type or resolution for that matter. And what is additive manufacturing on that level? As a manufacturing process, what is its key property? It's additive shaping. Additive shaping means that the workpiece is built up. Every manufacturing process has a workpiece. So as the part is being produced, that's called a workpiece, is built element by element by adding one element after another, and that the number of elements is large, so that you have many elements that make up the workpiece. Otherwise, you could say that injection molding is an additive shaping process, has the additive shaping property, just because it's one large part you build at once through casting. So that's one thing, and the other thing is that you add the elements. So it's many subtractive processes like CNC. You could also say work element by element, but they work by removing element by element, and that's also very different. So that's the core nature of additive manufacturing, the additive shaping principle, which is also encompassed in ISO ASTM 52900. So I work with the 2015 version. There has been a new version since then, and that's an evolution. That this additive shaping principle differentiates additive manufacturing from all other manufacturing processes in my mind, right? So you also have there's also other ways of classifying manufacturing processes. In German, there's a DIN norm that specifies 6 different types of manufacturing, which is Umformen, Urformen, Trennen, Fügen, Beschichten, and Stoffeigenschaften verändern. Of course, primarily I would say for mechanical components. And you could actually take this model and try to explain additive manufacturing that way. It would work theoretically, but I don't think it would in the end be a satisfying conclusion, in the sense that you have a model that actually explains things to you, like when to use this process or not, and what are its advantages and so on. So from the additive shaping principle, a bunch of stuff is already derived, like theoretical multi-material capability. Of course, that depends a bit on what type of what deposition mechanism you use to deposit the feedstock, but that's already one level below that. So that is really the very first thing. And then the second key property is that additive manufacturing is tool-free. So that means that you have a manufacturing system that provides implements a manufacturing process that you can use to manufacture parts, and that this manufacturing system is fundamentally not restricted in what shape it produces, so what size the part and what the individual geometric features are. And it means that you don't have to tool the machine before you want to make a part of a certain shape. Of course, that also extends to material and some other properties. And that is really special, because when you have a tool-free manufacturing process, it automatically enables certain application features such as mass customization and fast iteration, iterate after launch and all of those things. So the tool freeness is something that gives AM a lot of flexibility and agility, and that is this agility that it brings to manufacturing is actually what motivates me the most, because I always think that agility is great for development, and I'm familiar with it from the software development side. So really, that's one of my key interests, is to bring this agility to manufacturing via additive manufacturing. And you could imagine that if you could have a process, a particular machine that makes a particular thing, perhaps a turbine blade or something like that. If the process is so tooled due to certifications and other things that you cannot change what type of turbine blade it makes, or you cannot make another thing, then you may still have the additive shaping principle, but you may actually lose one of the core properties of additive manufacturing, which is the tool freeness. And that, to me, I think is really essential property of this process. And then the third thing is a bit more abstract, or a bit more indirect than the first two properties. That's it, and I call it the digital nature of it. But I think it has to be explained a bit more, because nowadays everything in manufacturing is already digital, so I think it has to be a bit more specific. And that is that most AM processes use layer-wise additive manufacturing, and layer-wise additive manufacturing by default means that toolpath generation is autonomous. So you can auto-generate the toolpath using a computer, which your slicers do, if you're familiar with it. And that works pretty much automatically. Of course, you set it up, you place the part, you orient the part, you give the settings and so on. But the toolpath generation is fully automatic. And you rarely, except for some special cases, you do not really have to, for a general case, you do not have to inspect the toolpath afterwards. Of course, we do often do that many times for many reasons, and there's specific things such as heat spots and laser powder bed fusion and a bunch of other stuff where you really have to pay attention. But in general, toolpath generation is autonomous and it's fast. And that is a big differentiator to technology like a manufacturing process like CNC, which has fairly long tooling, except for reduced cases of complexity where the toolpath generation can also be autonomous. And this leads to also to agility, to a quickness in production, and also to low initialization costs. And that's really the thing. This is why it's possible to do one-offs in additive manufacturing, whereas this is much more harder or much more expensive in other manufacturing process, even one that is virtually tool-free, or for the largest part tool-free, such as CNC. I know that you need to put certain tools in the machine for a CNC machine to make a certain part, but let's just assume that the machine has a tool changer. And that is really a key enabler, and of course that applies to layer-wise additive manufacturing primarily, but we would have to say that most processes and the FDM that we deal with is layer-wise, and the non-layer-wise AM processes, mostly for the most part, that's direct energy deposition, and that is used to produce large components for aerospace, for aircraft and space both. And those processes, I would say, are heavily tooled, so that does not go in the direction of having a generic manufacturing device that can make parts of all shapes and kinds. So that's where you see that even though you have the additive shaping principle, kind of the differences dissolve a little bit, and even an AM process could be in the way that it's being handled, or the way that you can utilize it actually is more similar to CNC than to a general AM process. But that is how it is with any real implementations. So these are the three key properties of an additive manufacturing process. It's digital, it's tool-free, and it uses the additive shaping principle. This video got much longer than I expected. I actually just wanted to record a short, but I guess I got carried away, which happens when I talk about additive manufacturing. So I'll figure out the way how to upload this as a normal video, I suppose. And if the video is so long already, I'm planning to produce more videos about additive manufacturing. I used to be a trainer for this. I was training people in build preparation for laser particle fusion and other things, but also for design and also for other processes. And so I've built up a lot of content there and topics there, and I also think I can speak about additive manufacturing a bit more, also from a more general perspective than particularly the FDM we focus on at GRUM. So if you are interested in additive manufacturing in general and FDM in particular, I would appreciate it if you follow this channel. So, and also then you would get new videos. And of course, I would love if you give me a like, that's great, but also a comment. So I'm really interested to hear your feedback. What do you think about my AM model? Do you have any particular questions about this? So I'm really here for you, and I would love to answer your questions. So thanks very much, and see you soon with the next video.